Hi, in this video, we're going to take a look at a few additional variable types that can be used in our Arduino programs. Let's get started. We have learned about and used three variable types in our programs so far: int, which holds an integer value, float, which holds a decimal value, and bool, which holds a Boolean value, true or false. At this point, the most common variable type we have used is int, because many of our programs require us to keep track of whole values. But there is one issue we can run into when using ints. A variable saved inside an int type has a fairly limited amount of storage. The number saved inside an int must be larger than negative 32,768 and smaller than 32,767. Now, this might not seem too limiting when we think back to programs we have been building up to now, but as we delve into this module and begin to create more complex programs, we will need the ability to store values at a larger capacity. Lucky for us, more variable types exist that can do just that. We can use the long variable type to store values on a much larger scale. Due to the larger storage capacity of long variables, we can store values less than negative 2 billion to more than 2 billion. This gives us a much larger range of values to work with, which will come in very handy when we begin to do things like store time in milliseconds. Let's take a quick look at the function that will allow us to do this, millis. We can use the millis function to count the number of milliseconds that have passed since the Arduino began running our current program. Think back to the garden system program you developed in the last module. This program monitored the environment of our garden and altered the settings to allow our plants to thrive. What if we only wanted this program to begin monitoring the variables at night? We would need to keep track of when the program was started and how much time has passed to stop checking the sensors after a certain time has passed. The millis function can help us do this, but we would want to keep the program running for days on end to continue monitoring our plants. If we used a long variable to store the time that had passed since the program begun, how much time would be able to pass while staying in the range of values that can be stored? Well, our time would start at 0, and could increase until it reached the top value of over 2 million given here. This means we can store over 2 million milliseconds of time. If we begin with this many milliseconds, we need to divide by 1,000 to find the number of seconds this is. Then we divide by 60 to find out how many minutes this is. We divide by 60 again to determine the number of hours this amounts to, and divide by 24 to find the number of days. This means that using a long variable type to store time in milliseconds would allow us to run our program and keep track of time for almost 25 days. This is great, but there is one slight change we can make to the long variable type to allow us to keep track of time for nearly double as long. An unsigned long variable has the same storage capacity as a long variable, but instead of using half of the storage capacity on negative values, all values stored in an unsigned long variable are positive, so we can store values up to more than 4.2 billion. When used with the millis function, we are able to keep track of time for almost 50 days. Because of this, the millis function always returns an unsigned long variable. In the next exploration, you'll be using an LCD, or liquid crystal display. An LCD is an optical device that uses the light modulating properties of liquid crystals combined with polarizers to display images. The screens we'll be using can display 2 lines of text of 16 characters each. There are 16 connection points, but in our programs, we'll only use 12 of them. You don't need to know the placement of all of these connection points, but this is a good reference if you need one. In this lesson, we learned about 2 new variable types and how the millis function can be used to keep track of time. Now it's your turn to explore these on your own.